Hi everyone, this is Mrs. Crayer here. We are on the new packet. This packet has been condensed. It is our last 2 units, just the most important stuff from the last 2 units. Now I've got 3 pages to get through today, so I will probably talk a little bit faster. I may or may not skip some things. And if you need to, slow down, you could always pause it, go back, play it again. You have that ability because it is a video. Okay, so starting out, the first few days of this packet is going to be what would originally be Unit 12, statistics. Okay, univariate statistics. Just like a unicycle has one wheel, univariate statistics. I'm going to put a 1 in that spot. The collection, organization, analysis, interpretation of data that has one variable. Usually numerical data that is collected. Quantitative data, that is numerical data. Okay, we will see other kinds. If you continue to go on to Algebra 2, you'll see a lot more, but for right now, we stick with the basics in algebra. Okay, mean. The mean, you should be familiar with that word at this point. That's when we find the average. Now, the mean in the calculator, and we're not there yet, but when we do some statistic stuff in the calculator, this symbol is what is used for the mean. So I'm just going to write that there, and I'm going to put in calc. So if you ever see that symbol anywhere, that's used for the mean, which is the average. The median is the middle number. If you list out all the pieces of data, whatever number is in the middle, you list them out in chronological order. That's your median. In the calculator, it's MED, which is nice because I think that's pretty obvious. That's what it's going to look like in the calculator, MED. Okay, now, these are both statistical measures. Sometimes it's good to look at the mean, sometimes it's good to look at the median. One thing to note is that the mean, put a little star here, is used to describe the majority when data is symmetric. And that's not going to mean too much right now. By the end of the page, that'll mean a little bit more. But, we always talk about the mean or the average, especially teachers. I give a quiz, I give a test, and I might say, the average on this quiz was an 85. Okay, well, that gives you a little bit of a oh, okay, I got an 87, I'm right there, I'm a little above the average. Okay, or, oh no, I got a 65 on this quiz, I'm way below the average, everybody else seemed to do pretty good on this. That's what the mean is, okay? A better predictor is usually the median. So in my grade book, I actually write both of them down. I always write the mean and the median. But as the math teacher in me is always looking at the median, because the median's always a good measure. Okay. Analyzing. This first thing is a dot plot. And it says Charlie's Food Factory currently employs 28 workers whose ages are shown below on a dot plot. So there's 28 little dots on that thing, okay? We're going to answer the following questions looking at the dot plot. How many of the workers are 18 years old? Okay, we're going to go right to where 18 is. This scale, quick assessment of the scale goes by 1. So 15, 16, 17, 18 is right there. So how many dots do I see there? 4. So 4 of the workers are 18 years old. What percentage? Well, a percentage is always going to be part over whole. So I have 4 workers out of, and I can count up the dots, but they told me there were 28 total, so I'll trust them. Out of 28, that's going to give me a decimal, and I just did this in my calculator, 0.14 2, and it keeps going. So I'm going to say approximately 14%. When it's a percentage, we're going to move that decimal 2 to the right to put the percent sign on. Range. When you are finding the range, you find in this case, the oldest worker, and you subtract the youngest worker. So the maximum age I have is 42. And the youngest worker I see, even though there's a 15 here, there's no dot above it, the youngest one I see is 16, so minus 16. And that's going to make the range 26 years. So that takes the max minus the min. Would you consider this distribution symmetrical or skewed? So that's what I said by the end of the page. This is going to come back up. So I'm going to say this one's skewed. I'm going to get my highlighter out here and I'm going to show you. If I kind of go over this, in order for it to be symmetric, I'm going to draw it off to the side. We would want it to look like this, okay, where I could kind of, draw a line in the middle and it would be symmetric. This is skewed. We would say it has a tail to the right. So anytime you have a tail in the data, if you draw it like that, that's going to be skewed. So I'm just going to circle skewed. How can I tell? It's not balanced. And I would say it has a tail to the right. In which case we would say it's skewed right. So because the tail is on the right side, we would say it's skewed right. All right. So I'm going to come back up here real quick. So when I said that we use the mean when data is symmetric, that means the mean is a good measure when your data, and I'll kind of just draw a little picture over here, is symmetric. Okay. Going back down. The mean age for a worker is 22 years old. Why is this value not representative of typical workers? Because data is not symmetric. So in this case, I would want to use the median. Okay, the median would be a better indicator. Next page, histograms. So now you can see this colorful picture that we have over here. That's a histogram. The following histogram shows the ages of people that say M&Ms are their favorite candy. How many total people surveyed chose M&Ms as their favorite candy? Well, that's going to be everybody in the survey. Now, the way this is, it's not like I can count exactly like I could on the dot plot. So we're going to have to do a little bit of estimating. So the ages are the x-axis, 0 to 5, 6 to 10, 11 to 15, and so on. The number of people in each category, that's the y-axis, and you can see that we're going to have to estimate a little bit. So we're just going to use my numbers. And I said that this first one was about 2. I said the 6 to 10 age group looked to me like it had about 28. Again, I'm estimating. I said the 11 to 15 age group, that looked pretty much in the middle of 40 and 50, so I said 45. The group 16 to 20 looked to me like it was above 50, so I said 52. The 21 to 25-year-old, I said that was about 38. And then the last group, I said that was about 27. So then I took all of those and added them together, and I got 192. And again, I'm going to put approximately just because you saw how I was just approximating. What age range had the most people say that M&Ms were their favorite? 16 to 20. That seems pretty obvious to me. After what we just talked about, clearly you can see it's the highest for that age group. Why do you think the age range 0 to 5 had the fewest people like M&Ms? Well, some of these questions in the statistics unit just deal with a little bit of common sense. So if I'm thinking about a survey of people and I'm asking 0 to 5-year-olds, well, some of the people in that age group are too young to even eat M&Ms. So I'm just going to shorten that too. Some are too young to eat M&Ms. And one thing I'm doing here is just kind of giving like quick little statements. On an exam, you would make a full sentence out of that. Okay, some are too young to eat M&Ms. So 0 years old, a 2-month-old is not eating M&Ms. Okay. Next question, what was the age of the oldest people surveyed? Looking at the x-axis in this case, the age group, 26 to 30, oldest age group. E, would you consider this distribution symmetrical or skewed? Okay, so looking at the shape the same way I looked at the last one, if I kind of highlight over it, I would say that's symmetrical. Again, in algebra, we're going to be pretty basic about it. This one, I would say, is symmetrical. How can you tell? I would say it's balanced. That would be the word I would use. I just want to get out of this yellow pen. Here we go. I would say it's balanced. I'm going to say no tail. You know, for the most part, if I draw a little line down here, it's pretty symmetric. F, the mean age for a person surveyed was 18 years old. Why is this value a good representation of the majority surveyed? Okay, in this case, using the mean is a good idea. So mean is a good indicator of the majority. When data is symmetric. Sometimes that's hard to remember, and I think what's hard to remember about it is that mean and median both start with an M, and symmetric and skewed both start with an S. So there's like in our brains, it's hard to separate the two. But we'll regroup at the bottom and kind of state that again. G, what is better about the data on the dot plot that was the page before than the histogram? Okay, well, the dot plot is definitely better, I think, because it shows individual data. You saw when it asked me a question about like how many people, I could just go up and count the dots. The histogram was giving me groups, so it wasn't individualized. I had to estimate. Okay, recapping at the bottom. When data is symmetric, then either the mean or median values can be used to describe or represent the majority of the whole group. When data is skewed, not balanced, it has a tail, then only the median should be used to describe the majority. Okay, I'm on page 3, our last page for today. This is a box plot. This first sentence up here, you can kind of cross out. That was my bad. We don't need that sentence because it's written below. Box plot diagram uses 5-number statistical summary to create a diagram of the data. The values are separated into, zoom in a little bit, 4 parts is what we're going to write there. Each section represents 25% of the data. Okay, so we have a minimum value, min, As I go through the words that are listed below, I'm going to highlight where they are on the graph. So I'm going to be going through the words and highlighting where they are in the graph. So I've got my highlighter. These lines are what you're going to want to pay attention to. So if you see where I just did a highlight, these little vertical lines in the graph are going to be the most important parts of that graph. The one I just highlighted there, that's the minimum value. The one at the far right, that little vertical line right there, that's the maximum value. Okay, it's the high and the low. That should seem pretty obvious. Now, this guy, I'll go with the middle. That is the median. Okay, and then this little vertical line, the first one, that's the lower quartile. And the one on the other side of that box is the upper quartile. All right, so what do those mean? I mean, I think the low and the high are pretty obvious. The lower quartile, 25% at or below. So if your grade happens to be at the lower quartile at Q1 on a quiz, that's not a great place to be. That means that only 25% of the class was at or below your score, which means 75% of the class was above, did better than you. Okay? Median, 50% at or below. So if you have the median grade, then 50% of the students, were below grade-wise, 50% of the students were above grade-wise. Upper quartile, 75, that's a good place to be for a quiz grade. 75% were at or below your score. All right, so coming over here, I'm going to list out those 5 things we just talked about. I'm going to list them out for Mrs. Marsh's algebra quiz. The minimum value. And this goes by 2s. I'm looking at the scale. 50, 52. So that's right in the middle. So that minimum value is going to be 53. My Q1. Again, that next vertical line, it's highlighted in green on mine. 62, 64. 64 is Q1. The median, that's that little vertical line in the middle of the box. That's sitting at 71. Q3, median can also be called Q2. The Q3, 72, 4, 6, 76. And the max, the highest grade on this quiz, was 82, 4, 84. Now let's answer the questions now that we have the information that we need. Whoa. What was the median score on Mrs. Marsh's quiz? Okay, well, we already answered that one. Median score on Mrs. Marsh's quiz was 71. This just comes from being able to read a box plot, knowing that that line right there tells me the median. What was the range of scores? Okay, I'm going to take the max, which was 84, and I'm going to subtract the min, which was 53. That's going to give me 31. That was the range of scores. What interval of scores represents the bottom 25%? Okay, so going back, I'm glad they asked this question because what I would want to say here is this 25% of the scores fall in that range. 25% of the scores fall in that range. 25% of the scores fall in that range. That's how they're getting these numbers. 25% of the scores fall in that range. They take the class, they break them up into quarters. The bottom quarter, the lower bottom quarter, the top, middle, and the top quarter of the class. What interval of scores represents the bottom 25% of students? Well, that's going to be this section right here. There's my bottom 25%. That's going to be 53 to 64. What score? I'm on D. What score was less than or equal to 75% of all other scores on this quiz? That's that can be a tricky question. I guess just the way it's worded to me is a little bit tricky. So I'm going to erase a little bit here. What score was less than or equal to 75% of all other scores? And that's going to be this score right here. Let me highlight it. That score is below 75% of the data. So what is that score? That score is 64. Mrs. Marsh had 28 students in her class. How many of the students scored between 64 and 76? All right, let me figure out where 67 and 76 are. I'm sorry, 64 and 76. 64 is right here. 76 is right there. Oh, look. Okay. So that means 50% of the students scored between those two scores. Because keep in mind, going back to my highlighter. Sorry, I'm drawing all over this thing. This is 25%. This is 25%. So this middle is 50%. So 50% of 28 students, well, that's going to be half the students. So that's 14 students. Is the spread of the data symmetric or skewed? I actually don't want to ask that for this question. I don't love that question here because I think that, like I said, for algebra, it should be obvious. So instead of asking that question for this one, because this one, I could see students saying, oh, it looks skewed left, or I could see students saying, oh, it looks symmetric. So I really only want to ask you that when it's kind of obvious. What I am going to do is just draw a picture. I'm going to cross off that question. And I'm going to draw a picture of something that, a box plot that is like very clearly skewed left. Like that would be skewed left. Because the tail is on the left. Something like this would be symmetric. Okay, in a case like either of those, I think that those are pretty obvious, skewed, symmetric. All right, last piece. What was the interquartile range, the IQR? So this is just like range, but instead of doing the whole range, max minus min, we're just going to get rid of this portion and this portion. We're just going to do, where I have those arrows, we're going to do the interquartile range. So that means I'm going to take Q3 and subtract Q1. So Q3 was, I had it written up there, 76. And I'm going to subtract Q1, which was 64, and that's going to give me my interquartile range of 12. Okay, again, if you need to go back and look at any part, do that. Make sure you're doing homework 1, which goes along with this. All right, everybody, have a good day.